All right, today we're going to look at the last material for Chapter 8b. We're working on the second half of 8.6. We're solving rational equations, and we're using those equations to solve problems. So when we have binomials, we're going to put parentheses around them first, and then we're going to multiply everything by that LCD. Similar to what we did yesterday, except instead of a monomial in the denominator, we do have some binomials. So I want you to think of putting parentheses around those. Our technique for converting this so it's not a fraction equation and not a rational equation is to multiply everything by the LCD. And if we look at all of our little denominators, we have an n minus 8 for the first one, we have a plain 1 for our second fraction, and then we have an n minus 8 again for the third fraction. So our LCD for this one is just going to be n minus 8. So we are really taking that n minus 8, and even though we just put it out front of all of this, we are distributing that to every piece of this equation. So we're multiplying it to the first one. And again, if you think about taking n minus 8 times 1 over n minus 8, those n minus 8s are going to drop out, and we just get a 1. Multiplying it to this one, we have a negative 1 times an n minus 8 all over an n minus 8. The n minus 8s all over a 1. So our n minus 8 will not drop out on this one. We do have to distribute that negative 1 to both. So we're going to end up with negative 1n plus 8. And then when we multiply it to the last fraction here, we have 7 over n minus 8. We're multiplying it by another n minus 8. Those will drop out, and we get it equal to a 7. Okay, so we've again eliminated having fractions, and we just have a basic linear equation to solve. Combining like terms here, we have 1 plus 8 would be 9, so 9 minus n equals 7. We can subtract the 9 to the other side. So negative n equals negative 2, and if we divide out that negative 1, we end up with n being a 2. Going back and looking at our domain restrictions, our denominators, we know that n cannot equal a positive 8. We ended up with n equaling 2, so we should be fine. All right, our next example, looking at our fractions, our denominators, we have one that's an x plus 2, and we have one that's an x minus 2. So in this case, our LCD is going to need to have both of those. Okay, and we're going to have to pay real close attention to what's going to drop out here, because we're going to take this whole equation and multiply it by x plus 2 times x minus 2. I'm going to put a 1 under there just to show our fraction part. Okay, so when we go to distribute that to the first one, let's look at what happens. We have an x plus 2 times an x minus 2 all over a 1. We're multiplying it to 2 divided by an x plus 2. In this case, the x plus 2's drop out. What we have left is 2 times x minus 2. I'm actually going to move that down, give myself a little more space here. Okay, so that's the first part. Then we go to multiply it to the second fraction. So we have an x plus 2 times an x minus 2 all over a 1. We're multiplying it to x divided by x minus 2. So now our x minus 2's drop out. We still have this. We have an x times an x plus 2. Okay. On the far side, when we multiply it to a 1, nothing's going to drop out. We're just timesing by 1. It doesn't do anything. So we still have an x plus 2 and an x minus 2. All right, now we have to clean this up a little bit. So let's go ahead and distribute. We get 2x minus 4 plus, we get an x squared plus 2x. On the other side, when we FOIL that out, we end up with x squared, insides outsides will cancel, and a minus 4 for the last term. All right, now notice we have some x squareds, but we have one on each side. So if I start to move this one over, it's going to end up dropping out. All right, combining our like terms, 2x plus 2x, this side would be 4x minus 4 equals negative 4. I can add 4 to the other side. We're left with 4x equals 0, and 0 divided by anything is just 0. All right, so we end up with x equaling 0. Now we go back and we check. Was that a restriction from our domain? In this case, x cannot equal a negative 2. Here, x cannot equal a positive 2. We ended up with an answer of 0, so we should be fine. It's not one of my restricted values. Now, I'm going to go through an example where we do have an issue with the restricted values. So we are going to add one to our notes today. When you have rational equations with quadratics, make sure that we have it in factored form first before we try to find our LCD, because we don't want to over multiply. We don't want to multiply in more than we absolutely need. And again, we always want to check for those extraneous solutions. So looking at this, right here we have a quadratic. If we factor that, we can think of it as r minus 5 times r minus 2. Okay? So in that form, if we look at all of our denominators, one of them is r minus 2. We have another one actually that's the same thing. And then we have another fraction that has both of these. So our LCD for this one is going to need to have an r minus 5 and an r minus 2. Okay? So we are going to multiply this whole equation by those two pieces. All right, so what's going to happen? When we distribute that to the first one, we have 1 over r minus 2. We're multiplying it by both an r minus 5 and an r minus 2, which means that the r minus 2's are going to drop out. And 1 times r minus 5 would be r minus 5. Okay, so that's this first fraction converted. Okay, then it says I'm adding to it. Now when I go to multiply the second one, I had 1 over an r minus 5 and an r minus 2. When I multiply by both of those, all of this drops out, and we're left with just the 1. On the other side of the equation, we have a 6 divided by r minus 2. And we're multiplying it by an r minus 2 and an r minus 5. Okay, distributing that in. And this time the r minus 2's drop out, and we're left with 6 times r minus 5. Okay, let's simplify now. We don't have fractions anymore. So r minus 5 plus 1 would just be r minus 4. On the other side, if we distribute that 6, we get 6r minus 30. Combining our terms onto one side here, I'm going to subtract an r. That leaves me 5r. And I'm going to add the 30. 30 with a negative 4 would get me 26. So r is going to end up being 26 divided by 5, which comes out to be 5.2. Okay, looking at my domain restrictions on this one, we know that r cannot equal a 5 and r cannot equal a 2. So since we're getting 5.2, we should be okay. All right, let's try another one. This one has an x minus 3, an x plus 3, and an x squared minus 9 as denominators. But in factored form, x squared minus 9 is just x plus 3 and x minus 3. So there's some overlap here with denominators. My LCD is going to be both of those, x minus 3 and x plus 3. Okay, so picture multiplying this whole equation by an x plus 3 and an x minus 3. Okay? When we multiply it to the first fraction, we have x plus 3, x minus 3, and we're multiplying it to x divided by x minus 3. Now the x minus 3's drop out, and x times x plus 3 would give us x squared plus 3x. Okay? Distributing it to the second fraction. Now I have x plus 3 times x minus 3. I'm multiplying it to x divided by x plus 3. So my x plus 3's drop out, and I have x times x minus 3, which ends up being x squared minus 3x. And when I multiply it to the last one, since I have both an x plus 3 and an x minus 3, and I'm multiplying now by those, they're all going to drop out and leave me just with the 2. All right. So we end up with this equation. Simplifying the left side, x squared plus x squared would be 2x squared. The 3x and the minus 3x are going to cancel each other out. So 2x squared equals 2. I'm going to divide out the 2, so x squared would be 1. And remember that when we square root, we need plus minus. The square root of 1 is just 1, so x is going to equal plus and minus 1. My only domain restrictions were that x cannot equal a 3 or a negative 3. I'm getting 1 and negative 1, so both of these answers should work. All right, before we tackle our last word problem here, I do want to add one and show you what's going to happen when there are issues with that domain restriction. So let's look at, this is actually from your worksheet, today's worksheet, number 3. We have 1 divided by x plus 1. We're adding 1 divided by x minus 1. And we're supposed to get 2 divided by x squared minus 1. All right, so in factored form, this becomes x plus 1, x minus 1. So our domain restrictions, we are saying that x cannot equal a negative 1 for here and a positive 1 there. Okay? Going through our process of multiplying by our LCD would need to have both an x plus 1 and an x minus 1. So when I multiply this whole thing by both of those, when I distribute it to the first one, the x plus 1s should drop out. So we have 1 times the x minus 1, which just gets me x minus 1. When I distribute it to the second fraction, now the x minus 1s drop out, and I have the 1 times the x plus 1, which is just x plus 1. And when I distribute it to this last fraction, both the x plus 1s and the x minus 1s would drop out, leaving me with just this 2. Okay, combining like terms, x plus x is 2x, negative 1 plus 1 is 0. So 2x equals 2, which gets me an answer of x being 1. However, we set up here that x can't be a 1. So when my only solution is actually something that my x is not allowed to be, I say there's no solution. So you will have a few examples on today's worksheet where you end up with the answer you're getting is actually one of your restrictions. So you say no solution. All right, our last question that we're going to look at. It says, a flight across the U.S. takes longer going east to west than it does west to east. Assume that winds are constant in the eastward direction. When flying westward, the headwind decreases the airplane's speed. When flying eastward, the tailwind increases its speed. The time for a round trip shown at the right is 7.75 or 7.75 hours. If the airplane cruises at 480 miles per hour, what is the speed of the wind? All right, so we are going to define x as the speed of the wind. And then remember that we have this formula, rate times time equals distance. So if we were trying to solve rate times time equals distance, to solve for t, we would have to divide out the r. So t equals distance divided by rate. And they're talking about a round trip flight. So the total time is the time that we are going from west to east plus the time that we're returning going east to west. All right, we have a chart here. On going west to east, our total distance is 1,850 miles either direction. So notice here that our distance is the same for both directions of our trip. However, when we are going from west to east, the wind is helping us. It's going in the same direction. It's going eastward. So it's actually pushing us. So our rate or speed that the plane is flying at is the 480 plus what the wind gets us. But when we're flying the return trip going east to west, the wind is going to slow us down. So we're taking our 480 miles per hour and we're slowing it down by whatever that wind speed is. And we said that that time is distance divided by rate. So our time here is just our distance value divided by our rate. So for going west to east, it's 1850 divided by 480 plus x. And going east to west, it would be 1850 divided by 480 minus x. So we have to solve this equation. Total time, 7.75 hours, is equal to the time going west to east plus the time going east to west. So adding these two up. Looking at our denominators, we have a 480 plus x, we have a 480 minus x. So our LCD is going to need to have both of those. All right, so we are going to multiply this whole equation by both of those. On the left side here, when we multiply it to the 7.75, there's nothing that's going to drop out. When we multiply it to the first time here, 1850 divided by 480 plus x, the 480 plus x's would drop out. We're going to have 1850 times 480 minus x. When we distribute it to the last piece here, the 480 minus x's would drop out, and we have 1850 times 480 plus x. Now, we have some larger numbers here, so grab your calculators. If we take 480 plus x times 480 minus x, the insides and outsides will drop out. But 480 times 480 is 230,400. And then the x times the negative x would be negative x squared. So distributing the 7.75 to that, we end up with 1785600. So 1,785,600 minus 7.75 x squared. All right, on the other side, distributing 1850 times 480 ends up being 888,000, and 1850 times negative x would be negative 1850x. Distributing here, we're going to get another 1850 times 480, so 888,000, but this time we get plus 1850x. So the minus 1850, the plus 1850x's are going to drop out. We end up with 888,000 plus another 888,000, which is 1,776,000. All right, to solve this, we're going to get our x squared by itself here. So we're going to subtract this over to this side. 1785600. That leaves me negative 7.75x squared equaling negative 9,600. And then when I divide out my negative 7.75 and square root, I end up with x equaling 35.2, and that would be miles per hour. So we divided, I don't remember what our x squared number was, and then we square root that. Normally we put plus minus there, but we can't have a wind speed that's negative. So we're only looking at the positive answer of 35.2 miles per hour. All right. Let me know if you have any questions on this last section.